Thank you so much for inviting us. But I am going to let Raul do the first part of the introduction, and then I'll get more into the weeds after he introduces our project.
Yes, good afternoon. Good afternoon to you all, and thanks, Shital, for the invitation to participate with your group. Robin and Paul Gottlieb, our other collaborator, he actually was the lead person on this project, and myself, we have been involved in this project trying to help the nursery industry here in New Jersey. Now, just for the record, and Robin will introduce this too, New Jersey, despite its small size from a land point of view, we still make it to the list of the top 10 nursery producers in the country, as far as the USDA statistical office is concerned, with the records. So the nursery industry, along with other industries, they make up for sort of the bulk or the primary crops that bring revenue to the state's coffers. So today we will be sharing with you, I'll just do the introduction, about this tool that was developed over the course of a few years with funding from the USDA NRCS to look at the average grower or farmer, to look into the investment and return on investment on building a water recycling system that will allow them to capture their water runoff and reuse it in their operation, particularly if they have issues with water availability, or if they want to kind of go ahead of the regulations, environmental regulations that might come down the road. So here, this slide, you can appreciate right at the bottom of those different components of New Jersey's agriculture, where nursery, greenhouse, and floriculture, including sod production, rank compared to the rest. So the green industries, as we call them, excluding the landscape management or maintenance component, which will be adding another significant value to the economy, the green industries remain the principal agricultural activity in the state. Now, there are some caveats with it, and if you could show the next slide, please, Robin. These green commodities, particularly on the production side of things, ornamental plants that are grown in greenhouses and in nurseries, are characterized, as probably you have heard from other presenters, by a heavy use of water and agrochemicals, fertilizers, water chemicals, and fertilizers. And unfortunately, the use efficiencies of these inputs are relatively low, to say the least. And it is not only for these industries, but agriculture in general. For example, the literature tells us that the nitrogen use efficiency, that's the abbreviation for NUE, it is relatively low for agriculture in general, where no more than 50% of the fertilizer applied to agricultural crops, it is actually picked up or harvested with the crop component that it is sold, whether they're field crops or greenhouse or nursery crops. Water use efficiency kind of goes along the same lines. But of course, in irrigated agriculture, it just depends the type of system that we have, how much water we put and how much actually is effectively applied and utilized by the crop. For nursery production systems, where we use overhead water irrigation, unfortunately, the application use efficiency is not that good, because more often than not, the largest part of the water that we applied falls in between the pots and not inside of the pots. So we can be losing to runoff as much as 70% of what we applied. So this has consequences. If you can show the next slide, please, Robin. Well, here's some data that we put together a couple of years ago for a book chapter. where I tried to come up with some numbers to give us an idea of the application rates of water and nitrogen fertilizer to ornamental commodities, going from field nursery stock and then lawns for the landscape industry, and then some greenhouse and nursery crops. As you can see, container nursery stock, the production of plants in outdoor environments, but in pots, in growing media, we have fairly high nitrogen application rates on an annual basis, anywhere from 900 to 2,500 pounds of nitrogen per acre per year. On the water application rates, 60 to 80 inches of irrigation per year are sort of the norm, or they're kind of common. Now, if you take into account the use efficiency that I mentioned before, what we're looking basically, it's a waste of a lot of water if we don't recycle that water. We're going to be wasting it, and that water that is going to be drained or coming from runoff from these growing operations, they're going to be loaded, rich with nutrients. Next slide, please. And we're end up with situations of this nature. Now, depending on where you are in the country, there are going to be some states that have some regulations where they're trying to minimize the environmental impact of these activities. So they're putting stops to the industry. For example, we know that in California, Nevada, and perhaps in Utah, they're looking at this. And of course, these states in the western part of the country, they're drier. So you also are having problems or issues with availability of water, primarily from primary water sources. So recycling becomes an option to be able to, reuse that effluent, which is rich in fertilizer. And then that way you can supply the needs of your crops, as well as minimizing the environmental impact, because you are allowing that fertilizer to be reused by the crop again, and minimize these problems, environmental issues that are a headache in some parts of the country. Next slide, and Robin takes it from here.
Okay, thank you, Raul, for that introduction. So, as Raul mentioned, in New Jersey, we have some of the larger growers have been switching to water recycling, not because of regulations, but mainly because they fear regulations down the road. Whereas in California, there already are regulations, and I've been hearing this for as long as I've been in the industry. I've been at Rutgers now 35 years. I was at Penn State in the horticulture department for 5 years before that. And during that time, I've been growers worried about future regulations. So we tried to sort of head it off at the pass by looking at the cost and other factors to consider when you're going to recycle your water. Obviously, recycling has benefits in terms of conservation, but producers are in business to make money, so it also costs money. So, that's the big question, is what are the costs and returns of doing this? Irrigation is probably a bigger issue in California, Nevada, and Utah than in New Jersey, because we have plenty of water, but we also are the most heavily populated state in the country. So we have the most regulations, and we have constituents that live close by that are going to be unhappy if we start polluting. So what we find is the large producers have adopted recycling, but the smaller ones haven't. And that's because recycling has a large upfront cost. The precursor to this project actually started in 2014, when we had a really interested undergraduate student, Alyssa De Vincentes, who I think is maybe at UC Davis now. But she was very interested in water recycling from an environmental point of view. We are finding a lot of the students in college age now are very interested in environmental concerns. So she did an honors project. She went to several nurseries in the state that were recycling and asked them to describe their system. And we tried to get a handle on the cost at that time. And so this kind of summarizes the different options that you have in terms of water recycling, the advantages, the disadvantages, and the cost. So there's the sand filtration system. I don't think we interviewed anybody in New Jersey that was doing that. The advantage is it doesn't use chemicals, but one of the big concerns that we constantly run into when nursery people want to recycle is if you're recycling the water and there's pathogens in that water, that gets spread to every crop that you have at your nursery. So you need to find a way to take those pathogens out. So that's a disadvantage of the soil filtration system, even though it's cheap as far as cost. Then there's membrane filtration, which doesn't use chemicals, but it has maintenance difficulties and it can be expensive. I don't think we have anybody doing that either. Heat with no chemicals, but that can be expensive to operate. Then ultraviolet radiation, we do have some producers using that. An advantage is that it has no chemicals, it's environmentally friendly, and it does start to control the pathogens, Pythium and Phytophthora, and it works more efficiently if you have good quality water, and it's fairly inexpensive. Then we have chlorination, which is simple, but it doesn't work if you have pH above 7.5. Then chlorine dioxide, that can work in poor quality water, but it has a high capital cost up front. Chlorobromide has 3 active ingredients, and it works better if your pH is below 7. It's a fairly low cost initially, but an expensive operating cost. And then ozone, where there's no chemicals, it works better below 7. It's expensive, but we think it will become less expensive in the long run. So those are the main systems that we're looking at. But the biggest drivers of monetary cost in the literature that we looked at was the upfront cost, mainly of digging the retention pond to return the water that you've recycled from the property back to, and then the regrading the property. But one benefit that we found from the sort of medium-sized and large growers that adopted this is you're recycling water, so you don't have to keep digging additional wells, and you don't have to buy as much water. So there are some financial benefits there. But we don't see many small growers adopting recycling, so we wanted to look at some kind of tool that would help them reduce or look at the cost of the investment and what they're facing if they wanted to go that way. So we came up with an online tool that would calculate the return on investment using actual inputs from producers, customized then to their individual situation. And we started out by looking at the literature, and we do have this tool now actively online, so we're looking for more feedback and make sure that it works well for actual users. But at the beginning, there's a waiver to make sure that we don't get sued, that this is an estimate of what your cost and returns are going to be. And then there's information about regulation, and then they get outputs on the environmental impacts as well as the cost. So they start out by choosing which of those disinfection methods they tend to use, and then we ask some general questions about how much water they're pushing through the system, the source of the water, and how big is their operation. And then we look at the spatial configuration, like the topography in the ponds, and then as many cost and returns factors as we can get for their particular recycling of water operation. So we basically have 3 modules that we tied together: the upfront capital cost, the operating cost, and then the revenue for their business. And to build the model, we looked at 2 different approaches, the bottom-up and the top-down approach. The bottom-up approach came from NCRS, Jersey cost sheets, information from vendors that work in the industry, information from these large growers that we surveyed. And then Ferraro, I think he was at Virginia Tech, I want to say, he did his Ph.D. thesis on water recycling. So we relied very heavily on his thesis, and he also published a paper in Hort Science in 2017. Then the top-down approach was a meta-study of articles where we could collect data from 38 different operations, where we had enough complete data to build the model with our programmers here at Rutgers. So you can see here we had different growers of somewhat different size, some nurseries and some greenhouses. And so you can come up with a curve that's fairly standard for what most of them are coming in out. This is from the top down results. So some of our challenges is most of this information comes from larger operations, so we don't know how applicable it is to smaller or medium, or I guess smaller operations. And can we customize return on investment when we're not actually at the nursery and we're asking them to input the information? Is their model too optimistic or too pessimistic? All the growers that we interviewed back in 2014 said that it wasn't profitable. They did this sort of for the good of society, and so they don't get regulations, but they also got subsidies, and they said without the EQIP subsidies that it would not have been worth it for them to do it. So that comes into a policy situation then. Is it something that we should invest in society wise so that we don't pollute our environment? So this is, a delicate thing to introduce to smaller growers because we don't see many of them doing it. Well, let's see. I'm having a hard time. Okay. My computer didn't want to advance. So there's several factors that we sort of came to a summary on as far as dominating the profitability of recycling. They probably need to build a pond or regrade land for better water flow. So that's the big upfront cost. And then these costs are so big that often it's not worth it for the grower to make this investment financially. If they're using municipal water, which mainly only the small producers are doing, it is expensive per gallon. So recycling may come into play then to sort of push the smaller growers over into considering recycling, because it's much cheaper once you have that well dug to water than it is if you have to buy municipal water. Again, we come back to economies of size. Recycling is probably less likely to be profitable for smaller operations, and because of that big capital cost, the earth moving, the pond construction, and the well construction. But we're finding, as nurseries expand, having to drill another well may then bring recycling back into play, because it can reduce the need to have to dig another well. And if producers already have a suitable pond and they're considering well drilling, they might find that recycling has a positive return on investment. So we use JavaScript to create the interface with a combination of Microsoft Excel, and this is the website where we have this tool located. So you can go there now. It's totally free. It was subsidized by NRCS, and test it out, and we'd be happy to hear feedback that you have on the tool. So this is what it looks like when you go to the website, and it takes you to those different modules that I talked about. So it asks the size of your operation, the topography, the irrigation flow, the cost of your public water, anticipated cost of well drilling, land availability, and so forth. So it kind of goes into this black box, and it looks at a partial budgeting approach. So we're looking at construction cost, increases in operating costs, decreases in operating costs, and we come up with a net present value. But as you can see, the producer needs to have some of this information available, or at least a fairly good estimate to use the tool. So then we tested it out as a function of size. And so this real trend line is where we think most people will fit. And we just played with it to see if we're spot on. So the 20% is our web tool with pre-existing pond capacity, and 25% is with pre-existing pond capacity at 25% of irrigation flow. So these are based on a costing approach, and we think we're pretty reasonable coming up with what the literature said things would cost. So 5 million gallons of public water previously used for irrigation on a 20-acre operation shows that the break-even point is if you're having to pay about 70 cents per 1,000 gallons of public water, that it would be worth it for you to invest in recycling. So that was our net present value kind of break-even point. And if the variable net benefits are significant, then the profitability can be increased with size, as we said before. And that's why I think we see that mostly large producers are recycling. It's a little bit more difficult to justify it on a cost basis for smaller operations. So it looks like about 30 acres is the break-even point from our model. If we could reduce some of these other costs, then of course it would be more cost effective at a smaller size. So again, this middle line is the website for our tool. We also have the farm management recycling series. We're just in the process of moving our websites, some of the websites at Rutgers over, and we're having a little bit of trouble because the person who set up this water recycling series for us retired, and we need his source data, but there is some basic information there, but you might get frustrated when you try to go deeper into this. But the recycling tool does work, and this is the website, and we also have other information on the Rutgers Farm Management website above. So I can stop sharing and take questions.
Thank you, Robin. So is there a way like you could show us how to navigate on those websites, like click on those links, and maybe we could do a hypothetical entry or something so that people feel confident using those?
Okay, let me try that. See if I can, getting it shared both places. Okay, can you see it now?
Yes, we can see it now.
Okay. So we click here.
Yeah. Yep.
And do I wish to use it? And anybody want to give a zip code to try? Maybe we should stick with New Jersey just in case.
Someone from the participants said like 84790.
Okay, let's see.
84790.
Okay. Okay, so it says that your runoff is low, your drought risk is high.
Mm-hmm.
So we come up with a combined risk of 4 out of 6. Let's see.
Or you could try New Jersey if that's something.
Okay, let's see what they say.
Yeah.
Let's try Brunswick.
Okay.
So runoff is medium, drought risk is low, so combined risk of 3 out of 6. So our risk is a little bit lower than, I think it was 4 for.
Yes, it was 4 for us. So
okay. So
we go to the next model.
Okay, now it's going to get interest rates have gone up. We need to develop this. Rates were historically low.
Yes.
So what interest rate Probably at least 7 now.
Yeah, I
At
think
least 7. If you take an inflation rate, I think for the last month was 6 point something, so it's rounded to 7.
yes.
Okay. And how many acres?
Let's do 20, 30 acres, I guess.
Okay. And do you irrigate your stock using water from any source?
Yeah, you could choose any. Like, yes. Okay.
What percentage do you irrigate? Probably 100.
100%. Yeah, right. Yep.
Gallons per year.
This one, I wouldn't be sure, but anyone from the participant would like to tell how many gallons? I mean,
Let's see if anybody.
Some 20, 30 million, I guess. If the big nurseries in New Jersey, the ones that are 100 acres, 150, they use between 100 and 200 million. So maybe put 50 million, 50.
okay.
50 million?
Yeah.
I guess.
How many days in the year do you irrigate?
So let's put,
6 months, 180 days, I guess.
yeah, let's do 180. Yes.
And the number of hours per day?
Ooh, that's a good question.
There's an
The
average
growers there, how long you run your system in the, during the growing season per day?
per day. So for one site would be, I don't know, maybe 2 hours, I guess. That's like for, yeah.
Okay.
Again, it depends on, so this is all for the overhead system, right?
Yes.
Yes, we're mostly facing overhead. So we
Yeah.
now
Yeah,
we
the
need
bottom-
to look at percentages of public, well, rainwater, and tailwater. So
Let's put the the tailwater is the captured water by any means, right? The recycled water.
yes,
Whether or not it's recycled, but it captured. I mean, if it could potentially be used.
So yeah, so let's put 25% tailwater, and then the public water would be just 75. Usually we don't have well water, so, and we don't tend to capture the rainwater in tanks or pond.
so gallons per year. It doesn't like our gallons.
So let's put 0 for others. I think we left everything blank. So
Yeah, I think that's okay because, but it's saying
I think it's-
to go back up to the gallons.
I think it's how many zeros do we have? 1, 2, 3.
I think I put that comma in there and messed it up.
Okay.
Let's see. Do you capture in one or more ponds?
Yes, yes, at least one pond.
And Don adding ponds. Okay,
okay,
it says it's still loading.
loading your previous input. Okay.
Maybe I should click this.
Loading your previous inputs. Yeah, it's saying it's loading. So
It's taking a long time.
mhm. Maybe we were supposed to put pond dimension or what? I don't know.
I'm not sure. I'm not sure that we put how many ponds. If we had that option, or
How many what? Oh, ponds.
How many? Yes.
So
How many ponds? I guess you go one. You
Want to step back?
see if it'll let us without messing up. Oh, sorry.
We can go over this quick now because we know all the. And this will be very,
From last visit, yes.
yeah, so,
Yes, good.
So,
Good.
so awesome. So
Now, how many zero do we have on the water? 500 million or 50? 1, 2,
so
3,
50 million, that's 50 million.
50 million. Okay.
or we can also click, I'm not sure.
Yes.
Hmm.
And then I think we go next module or
Maybe we should save here.
yes.
Yes. Now link was created.
So
You need at least add. You need please fix the following error.
yeah,
So
add a pond. So we need, yes.
you need to add one. You need to put one. And now, what is the capacity of the pond? That's a good question.
Um,
Let's put at maybe what 50. What do you think would be good, Raul? So of course this will depend on the growers and everybody, but a good capacity, would it be 5,000, 10,000, depending on the size of the nursery? Okay, let's do, yeah.
10,000 gallons.
Distance between the pond. Okay, yeah, I guess because we didn't, somehow I didn't think we had this pond, we are missing.
Yes, the distance in yard between this point uphill to which its water would be needed to be pumped.
And yards, how many yards? If it is a 30-acre farm, let's put a 200 yards, I guess.
And then the grade.
In degrees, put 5%.
Yeah. Okay, I think this is it, right? Down 80 pounds.
Now say the input. Good.
Okay, so
No. Wait a
no,
minute, we didn't answer this question.
okay. It would say it says you need 7 this much gallons because we said 25% is recycling and we said 10,000 gallons, that's not going to put it. So I think we need a pond that has the gallon capacity of what's this one?
It's almost 3 acres is going to be tied up in ponds, is what it's telling us,
Yes.
based on the information we entered.
So I think because
So we can edit these
Yeah.
points.
Yeah, we can edit that for just the sake. Let's put the pond gallons to 8 million just for the sake of this because we put all those numbers in there.
Yes.
So how many zeros? What do I need to add? Let's see. 8. Is that right? No.
How many? No, that's too many.
That's too many. I think we need to delete how many? 3? Yes, 3. Delete 3. One more.
One more. Yes. There you go. I think that's 8 million.
Yes. So
Won't
yeah.
let me put
No,
commas.
that's 80 million. That's 80 million. I'm sorry. That's 80 million, right?
800.
Yes, we need to delete more, I guess.
One more.
One more.
That's it. That's 8 million. That's a
Yes.
million.
Yeah. Okay. And we're happy with, yeah, it shows us here. It's the
Yeah, because we said 25% and annual 50 million gallons. So at least I think that's how it says, because you said you would recycle 25%, you need bigger pond. If we had put like 2%, then we would go with small pond.
So we're happy here.
Yeah, we are happy here.
What's the cost of public irrigation, cost per 1,000?
50 cents, let's put that because the cutoff was,
No, that's for 1,000 gallons, or that per gallon? Because it's asking the price on.
yeah, what is your cost per
I
1,000?
remember we said break even was 70 cents.
70 cents.
Or was it
Yeah.
34 cents? Was it 70? Okay.
I think it was 70.
Yes.
So
70
we want to try 50 here.
Mhm.
Do we think we're going to drill a well in the future?
No, let's do no.
How much do we spend on fertilizer annually? We had a 20-acre nursery.
30 acre.
That's That's a tough question. Yeah. Obviously, a grower would know it. It's just,
Yeah, and I don't know if you have growers, you have educators, right?
yes, educators and also growers. Yes. So,
And fertilizer has gone through the roof this last
Yeah.
year, even if we knew it before. It used to be fairly insignificant, but I haven't really done a budget since the prices went up. Raul, you have any idea what a
Geez, with application rate, a bag of control relief fertilizer probably runs in the $50 for a 25-pound bag, and a 25-pound bag will give you 50, 25. Let me do it quick here. 50.
so maybe 40,000, or I don't know. But
Yeah, let's put $50,000.
Yes, yes.
Fertilizer.
Let's do 50,000. Yeah.
Green marketing. Do we want to look at green marketing, or we want to skip that for now?
We'll skip that for now. Yeah.
Calculate.
You need to save. Okay.
Okay. So
Okay. Yeah.
Did I? So
this,
capital replacement cost $687 a year. Electricity, $830, or basically $840. Chemicals, over 3,000. Labor's 800.
mhm.
So that's your cost to recycle, but
Oh.
your benefit is 36,000. So in this case, you would definitely recycle it. We put a really low price for water.
Mhm.
Um,
Did you put
We put-
70 cents?
We put 50 cents.
50 cents.
And in this condition, still we would be at profit?
Yes.
Okay. So yeah, so the idea, so the things we are seeing here, like analysis of potential changes to your annual cash flow, we would be saving more money by doing this recycling system.
Right.
So
Right.
this is,
Actually, even though we weren't paying much for water, but
yes. Okay, so this is
we're
what,
fairly big, we're big enough that we're kind of in that realm of,
But look at the fertilizer. The reduced fertilizer cost saving from recycled fertilizer, 30,000. If we're putting $50,000 annual fertilizer, we will be by recycling that fertilizer that goes into the runoff water, we will be saving 30,000. So we will
that's
be
true.
cutting.
Yeah, that's a
cutting
good point, because since the pandemic, fertilizer prices have really
Just
increased.
go through the roof.
So we're recycling fertilizer as well as water, so we're saving.
More than half of the annual fertilizer cost
Right.
for the calculation with the numbers we threw in there.
yes, and this is just a number that we threw in. A grower or a person would use this calculator and put their actual number, and the result would be very much applicable, right? Robin, is that?
Yes. Yeah, so I have somebody that wants to go back and check their zip code. Do we want to go back again?
I think someone in the question said, can you check for my area 30012?
So do we want to do that? We have time, right?
Yes, we have time. Yes, let's do it if we would like.
Let's see. We'll get back to the beginning.
And I would ask this participant to tell the area and other things.
Oh, yeah. Okay. So you have a high risk of runoff, a low risk of drought, but a high risk combined, 4 out of 6. So I think we did it on a 3. So interest rate.
We did 7%.
Yeah, let's put, I think.
7 again.
Yeah, if you would like to type in the 7, I think let's put 7. And the area, I don't know, let's ask the area.
Anybody? Somebody's typing anything in chat.
I just typed in asking, can you please let us know the area water cost per 1,000 gallon in water used? Or maybe we could put like, again, the same area, like what did we use? 30 acres?
30 acres, yes.
Do you irrigate?
And do you irrigate?
Yes.
Yes. Of
We said 100 before. We're sticking
yes,
with
yeah, we'll just 100.
gallons per year. This was. We could also click
50,000.
Sure.
Okay, let's try. I'm not sure. I don't know what that brings up. Okay, and how many days in a year would you run your irrigation system? Where is 30?
We said 180 before.
Yes.
Average hours, I think we said 2.
Yes, let's put 2. Mhm.
And let's see, I think we had
14 acres. The participant indicated that he or she has 14 acres.
Oh,
Okay,
14
let's go
acres.
back.
Well,
Go back.
yeah.
Okay.
And then how 14 acres? So 100%, how 180 days? Let's do that.
Now, what are your water sources for our participant from area code 312?
Public versus, well, they've got 4 options for sources of water. They have to total 100.
Yes.
Are you buying municipal water?
Okay. Oh, I'll let this participant answer, or I don't know.
Answer live.
Yeah.
I saw a hand raised for a second, right?
So if there was an option for me to allow the participant to talk, that would have been awesome.
I already click. I allow the person to answer live.
Yes. So I think the person can speak or type in the chat. Or we could do it what?
Well, what do we have before? 25 here and 75 below? Was that it?
Mm-hmm. We had 75 at public and 25 recycled. I think that was.
Oh, that's why it was profitable, because we're buying a lot of water.
Mm-hmm.
Recapture, right?
Yeah.
And did we need to add a pond or?
Yeah, we need to add. Yeah, we need to add it.
Yeah, let's do pond 1. What is the capacity of the pond? So
So
we
this
said
is what?
How many gallons?
For the last one we use 8 million gallons. What if this is half the size? Well, what if it is 4 million gallons?
let's do that.
Is that right? Did I have enough to write zeros?
Yes.
And then the grade, we did 5% before.
In distance, we did 50.
Or we did 200.
Oh, okay, 200. Yeah, okay. Let's do that. Okay.
So is this right? 1 pond, 4 million gallons, 14 acres, 14 million gallons per year. What's the cost? We had 50 cents before.
Yes, 50 cents.
I'm going to leave it that.
Yep.
Do you see? We said no, right?
No.
Not drilling.
And spending on fertilizer. I forgot what we.
50,000. But this one, let's put
It's half, so it's 25,000.
25,000. Let's do 25,000.
And we said no to green marketing, right?
Yeah. And these are all avenues where we can make more profit by telling
Okay, so we're saving almost, well, $3,600 in water.
$15,000 on fertilizers.
That's the biggie. So we're
Yes.
saving a total of almost 19 or
18,000.
19,000.
Mm-hmm.
The replacement cost, maintenance, 581. Electricity, we're using 292. Chemicals, almost 1,000. Labor, 800. So the cost are 2,600.
Mm-hmm.
So we're coming up with a net benefit of almost 16,000 based on those inputs.
Okay. So I think so this will give us a general idea on what would be the running cost and how much we would save annually on the pond, right, Raul?
Mm-hmm.
Yes, and again, the assumption here is that we are using chlorine as the main mode of disinfection, which is the standard. If I remember correctly, the model was built to use chlorine as the disinfection method for the water recycling, which will be the least expensive of the common ones.
Okay. And also, this doesn't take into account the initial cost for constructing the pond, right?
Right, because we said we weren't going to build a new pond. We were using ones we had. So
okay, so there is an option where we can even input like building a new
Right.
pond, and that would tell us how much would be the labor, what would be what, and then we could put that in as well, right?
Right. But we said no. We just
Yeah.
said we're going to use the pond we already have. So that would likely change the
That
equation.
that might change the equation, but we don't know the value of like the lumber or things like that right now on top of our head.
Yeah.
But
My understanding is that the most expensive part of doing the pond is if you do not own somehow the equipment to dig the hole, moving soil. When you're digging a pond, it can be
That's the big
extremely
one.
expensive to have it done by a company, a contractor. The people, and probably Robin can say more about this. I believe that some of the largest growers that have recycling systems here in New Jersey, they actually build their ponds, using their equipment and their personnel. So they did not hire somebody else, and they did it over the course of several years. So
Yeah.
they save a lot on that.
That equipment is very expensive, but if they already own it, then the additional costs aren't as much. That's a good point. But if you had to go buy that equipment,
yes, it's very big.
That would
But
be
again, there is an option to rent it as well. We could rent
Yeah.
it and just for a day or two, or ask them to come and dig it. So, and if we are saving like $15,000 annually with that pond, even though the pond would cost $50,000 or $30,000 or $60,000, we would recover that, right? And in few years. So, and then after that, we would be running profit. And also in Utah, as I know right now, we are getting more stringent on the amount of nitrate and phosphate that we can discharge, and by only for that we might need to build a pond or a wetland or something to clear out that water.
Right. Well, the other thing is, at least in New Jersey, people have been getting these equip grants. So you may be able to get that to recoup part of the cost. And right now, everybody's concerned about environmental issues. So you can also market this, the green, it's a green company. So it's harder to put an actual dollar on that, but that does have value, and consumers more and more are willing to pay for something they consider environmentally friendly. So there's lots of factors here, but this is something to at least get you started, and you can refine it to your own cost. And if you were looking to buy a pond, you could go and get these numbers much closer to reality and see what the impact would be for real.